Hello and welcome. Brandon here. Thanks for choosing my video. If you like the video, please give it a thumbs up. If you think someone you know can also benefit by watching, please share. And as always, please subscribe. I appreciate it very much. So let's go ahead and get started. Okay, so here's where we left off in the last video. Now we'll do a quick review to make sure we're all on the same page, and then we'll go forward from here. So recall that the natural logarithm of the odds ratio is equivalent to a linear function of the independent variables. So that's everything here on the left in the middle. So we have the logit of p equals the natural log of the odds, which is equal to a linear function of the independent variables. So beta 0 plus beta 1 x1. Now the goal here was to solve for p, because remember, in the end, what we're trying to do is find the probability of an event given a certain value set for the independent variables. So we take the anti-log of everything over here on the left, and we have p divided by 1 minus p equals e raised to the power of the linear function of the independent variables. So all we're doing here is some algebra. We're solving for p. Now we continue with that over here on the bottom left. We move some things around, do some very basic algebra, and we end up with p hat equals e raised to the power of the linear function of the independent variables divided by 1 plus that. And that is our estimated regression equation in logistic regression. And what this will allow us to do is when we run this regression in Minitab or R or whatever else, we are going to get back our coefficients, and then we can use those coefficients to find p hat, or the estimated probability. So a quick reminder about the data we're dealing with. So we have 1,000 observations. Credit score is our independent variable, and it is the applicant's credit score. Remember, these are people who are applying for a home mortgage. Then our dependent variable is approved. So approved is coded as 1 if the mortgage is approved, and 0 if it is not approved. So it is a binary, dichotomous, mutually exclusive variable, which is a characteristic of logistic regression. Now I'm only showing 15 out of the 1,000 observations on the left, but I just wanted to show you how the data is structured. In this case, it's very simple. So I went ahead and ran this regression in Minitab. And we're going to spend the next several slides going over the basic output, talking about what it means and how we can use it. So the first part of the output just has some basic information. So the method and link function is logit because we're doing logistic regression. There are others, but in most cases you'll be using the logit link function. Rows uses 1,000, that's because we have 1,000 observations. For response information, it just gives us a count. So for approved, a value of 1, we had 631 approvals. So out of the 1,000 observations, we had 631 mortgage approvals. So that means we had 369 that were not approved. So next we have what's called the deviance table. Now this can be read and interpreted in much the same way as the ANOVA table that is generated in linear regression. So we have a regression sources, and then over on the right we have a p-value. Now notice in this case we are using the chi-square distribution, whereas in linear regression we were using the f distribution or the f test. Now we're using the chi-square here because our dependent variable is categorical. But other than that, we can interpret it the same way. So for the FICO score, the credit score, we have a chi-square of 413.81. That's of course very high. And then our p-value is 0.000, which means it is less than 0.001. Now in the model summary section, again, we can read that much the same way. We have our r squared and adjusted r squared. In this case, it's 31.42 and 31.35 respectively. So in this case, about 31.4% of the deviance in the dependent variable, which is whether or not they were approved or not approved, can be explained by their credit score. Now the AIC we will not worry about in this video. Now next we have our coefficients table, and you can read this just like you did in linear regression. So our constant had a coefficient of negative 9.346. Our credit score or FICO score had a coefficient of 0.014634. Now if we look over to the right, they both have p-values of 0.000, which means they are both less than 0.001 and therefore are significant. Now below that, we have the odds ratios for continuous predictors. And we'll talk about this more in depth here in a few minutes, But I just want to point out one thing. Look at the 95% confidence interval for the odds ratio. If the confidence interval contains 1 or 1.00, then that means that increasing, in this case, the credit score by 1 point does not really change the odds any, and it does not have an effect. So always look at the confidence interval for the odds ratio, and if it contains 1, then that variable does not have any impact on the odds. So now let's go ahead and use our coefficients to estimate some probabilities. So here is our estimated regression equation. So we covered that in the very first slide. Now what we can do is take our coefficients and we can substitute them into this estimated regression equation. So here we have p hat equals e raised to the power of those independent variables. So beta 0 is negative 9.346. That's our constant coefficient up here at the top, plus 0.014634 x1. That's our FICO score or credit score coefficient up here in the top left. And then we do the same thing in the denominator. So there is our estimated regression equation for this specific problem. So p hat is the estimated probability of being approved, and x1 is any credit score we decide to put into the equation. So let's go ahead and do that. So at the top is the regression equation given to us by Minitab, y prime divided by 1 plus e y prime. And in this case, y prime is that regression equation we talked about in the last slide. So negative 9.346 plus 0.014634 times whatever FICO score we put into the equation. So here is our estimated regression equation from before. Now remember, we established that your credit score was 720 back in the very first video. So using that and our estimated regression equation in the orange up there, we can estimate the probability and the odds you will be approved for a mortgage using this model and your credit score. So here is the estimated regression equation we have before. We substitute in your credit score of 720. We do the math, and we end up with p hat equals 0.7668, or the estimated probability that you will be approved for the mortgage is 0.7668, or 76.68%. So what about the odds of you being approved? Remember, the odds are just the probability of an event divided by the probability of the event not happening. So in this case, the estimated probability of you being approved is 0.7668. Then we divide that by the probability that you will not be approved. So that's 1 minus 0.7668. And when we do that, we get the odds of you being approved of 3.289, or 3.289 to 1. Now, if you remember, I said we would come back to the idea of the odds ratio from the Minitab output, and here's where we're going to do that. So everything on the left is a repeat of what we did on the last slide. We found your estimated probability to be 0.7668 and your odds of being approved of 3.289, or 3.289 to 1. Now, what if we increase your credit score by 1 point to 721? Now, we'll go ahead and do the exact same process for a FICO or credit score of 721. So we substitute everything back in, but in this case, we have 721 for x1. We find the probability, and now we have an estimated probability of 0.7694. So on the left, with a FICO score of 720, we have an estimated probability of 0.7668. On the right, with a FICO score of 721, we have an estimated probability of 0.7694. So it's a bit higher. Now the odds, we can do that too, are 3.337. So on the left, with a FICO of 720, it's 3.289. On the right, with a FICO of 721, the odds are 3.337. Now, if we take the odds ratio for this 1 point increase, we have this 3.337 over here on the right, divided by 3.289 over here on the left, and we get 1.0146. Now, where have we seen that before? Well, remember, it's from our output. So the odds ratio for continuous predictors had a FICO score odds ratio of 1.0147. Now ours was 1.0146, and that's only because of rounding. So now we know what the odds ratio actually is. It represents the change in the odds for a 1-unit increase in the independent variable. So in this case, we went from 720 to 721 in our credit score, and we ended up with an odds ratio between those two of 1.0147. And that would be true for any 1-point change. So if my credit score was 692 and I raise it to 693, the odds ratio between those two is still 1.0147. And now you can also see why an odds ratio of 1 is problematic. If I increased my credit score by 1 point and the odds ratio was 1, well, increasing my credit score does not have any impact. So that is always why we look at the confidence interval on the right to make sure it does not include 1. So I think that's enough for now, and we'll pick up here in the next video. Thanks for watching.